And welcome everybody once again to the Daily Space Weather. I'm your host Dan, aka smAsho. We've got massive coronal mass ejections. We've got an Earth-facing coronal mass ejection watch in effect. Massive prominences. We saw a C-class solar flare happen yesterday. Lots of other exciting stuff to cover. Let's get things started by looking at a composite image of the sun here. You're looking at three different wavelengths, 211, 304, and 171 angstroms. And we saw basically a full sun outburst happen yesterday. And you can see activity on both of the southern corners here, the southwestern and the southeastern corner. And we'll have some close-ups for you momentarily. The 10.7 centimeter radio flux is at 83. There's the 1 year graph of that. Solon.info is back. And for you new viewers, thanks for tuning in, new viewers. The 10.7 centimeter radio flux is a measurement of the radio output of the outer solar corona. The sun's atmosphere puts out radio frequency, and we measure it. It comes out to be very proportional to sunspot number, as you can see on the graphs, depicting solar cycle 24. Discovered in 1947 by Canadian radio astronomers using some World War II radio equipment. And here we've got a 304 angstroms view. And check out the size of that prominence there around the western equator. Eyes on this area right here. Yowzers. And it did create a coronal mass ejection, which is actually still unfolding, taking hours and hours to fully release. Don't be surprised if we see an Earth-facing coronal mass ejection, although the ones that we've seen so far are not Earth-facing. So we're going to show you some helioviewer movies here. First, we're going to show you the view from Lagrange point 5. Yes, at stereo A. What's it look like from out there? Well, there's what it looks like from out there. You can see at the end of the video here a significant coronal mass ejection. Not in the Earth-facing zone, folks. The Earth would be out in this direction from Lagrange point 5. And just to help you visualize, there again is the view from where stereo A is located at Lagrange point 5. Here's another movie here, little higher resolution view from helioviewer.org. And we're going to show you some more toward the end of the video after we get through a bunch of other data. First, I'd like to thank our patrons, the true source of funding. Thanks new patrons, old patrons, and soon-to-be patrons. Please consider becoming one at patreon.com/smAsho. Help to support our efforts, as we're paid about nothing to make the content on YouTube. Although times are a-changin', folks. Times are a-changin'. So thanks everybody who shares the content on your social media, etc. Here's a full disc view of the local yellow dwarf, otherwise known as El Sol, the sun, in 171 angstroms. An ionized emission UV spectral state of iron. And we're going to show you one close-up as a teaser, and then we're going to move on to a bunch of other data. Here's what was going on in the past day in the northwestern quadrant. And you can see part of that coronal mass ejection down there. Now, we did forecast the naming of sunspot 2793, and we've been forecasting lots of things. Why? Well, because we noticed that nobody else is able to. And so we decided to pick up on that, since it's kind of important to be able to forecast what the sun's going to do next. Part of the reason why we have a channel. We're down to the less than a week of fall as the solstice approaches. We will be streaming live at the moment of the solstice. Where will you be on December 21st at 5:02 and 20 seconds Eastern Standard Time. We'll be streaming live. It'll be a YouTube exclusive. YouTube.com/smAsho. If you're watching any place besides there, make sure you tune in at that time so we can wish you a happy solstice as it occurs. And that's just the kind of thing we do here at the Smash News Network. We typically live stream all the time at solstices and equinoxes. So don't forget to press like and subscribe over on YouTube. Check out our playlists, youtube.com/smAshomash/playlists. And if you haven't checked out our smAshomash.org Presents the Sun series, if you like close-up imagery of the sun, make sure you check out that playlist. We've also got Smash Lights and daily space weather and all kinds of other content, not necessarily related to solar activity, thanks to our new subscribers over at BitChute. As we approach 300 over there, cheers. There is exclusive content. We are streaming live currently to Twitch. It's twitch.tv/smAshomash. And we regularly create live streams and exclusive content in all those locations. Also, don't forget to check out our own websites, smAshomash.com. Visit the links there. You'll find all of our social media. Come and interact with us on your favorite social media. And leave us a nice comment. Leave us a mean comment. We don't mind. Tell your friends, your foes, your science noobs, and your science pros about the channel. And thanks to everybody who's been sharing the content on the social media. Quick little revisit of yesterday's cosmology segment. We randomly selected T-Pix. And I wondered what that was. Well, it turns out it's a very interesting noval remnant, a repeating nova known as T. Pyxidis. And it's been observed to be going to a higher magnitude state in 1890, 1902, 1920, 44, 66, and 2011. So the repeating nova is quite interesting. The distance to it has been disputed. The current distance is believed to be around 16,000 light years, I believe it is. And so, yeah, that's an interesting one. We randomly selected it yesterday. And some folks are expecting this one to become a supernova. It's actually a binary system. And that is a composite image from Hubble Space Telescope. Otherwise, no cosmology segment today. We've got too many HelioViewer movies to show you. Next, we'll look at the real-time solar wind, which is showing a very low solar wind density. Solar wind density down to less than 1 proton per cubic centimeter. Solar wind speed quite low also, 327 kilometers a second. It looks like we see a coronal hole magnetism happening here over the past 12 hours. And we see a KP index of 0. Next, we'll show you the geospace magnetosphere movies. Velocity is fairly unexciting, but the density is going to show you a very low density, and you're going to see a very low pressure as well. We'll let all three play through today. That's 4 hours of data, by the way. And here's the density, and you can see that extremely low density solar wind showing in white, and some anomalous stuff happening there around the dusk side of the Earth. You can see on the equatorial plane, northern hemisphere around dusk. We see some oddities there in the plasmasphere. And the plasmasphere is the area held in place by the Van Allen belts. There's a bunch of plasma hanging out in those zones held in place by relativistic electrons. Next, there's the pressure, and it's some very low pressure. We'll let that play through. It's 4 hours of data, courtesy University of Michigan. And if you want to read about the space weather modeling framework from which this is derived, go to the Geospace Magnetosphere Movies page, click on Details, and click on Space Weather Modeling Framework. You can read all about the many, many different measurements that are used to create the model. Next, looking a little closer to home here at ground magnetic perturbations. I'm just finding out myself what's going on with this, and since we're living through a polar excursion, we've got two North Poles. The South Pole is nowhere near the geographic South Pole. It's now in the southern Indian Ocean. And we've got a North Pole over both Siberia and Canada. Let's let this play through a second time here. And we don't see a whole lot of induced magnetism here. And you see this kick up at times of geomagnetic storm. It does give you an idea of where you'll see the auroras. And typically that happens at times of, again, geomagnetic storm, geomagnetic unrest. We don't see any protons. We see the proton flux here at a background level. No proton events. There's that C-class solar flare, which happened yesterday around the heck. Around 1600. What is up with that? Around 1500 Universal Time. Oh, 1450, there we go. Around 1430 was around the peak flux of that. 1430 C-class solar flare, if you want to make yourself a movie about that. And here's a star chart. I use in-the-sky.org. The sun will be passing through Virgo and Leo and Gemini and Taurus today. And here's me vanishing. And a diagram of the solar system. There's where things will be in a week. And you can see Mercury if you look at the LASCO C3, part of the SOHO. Next, the ghost magnetometer is looking a little odd here. And thanks to the commenter who commented about arc jets create interference, which could create anomalous readings. So the data cites when the spacecraft turns on its thrusters. That's what the arc jet moments are. Thanks again to that commenter. Anyway, there's 3 days of data for the ghost magnetometers. And we have actually stayed in the North Pole current sheet. So that South Pole strength has dropped back down, which isn't that surprising as we see 2 sunspots in the southeast. So it looked like we snapped into the South Pole current sheet yesterday. It looks like maybe not. And we've got some newer data here. And there you can see some magnetic instability happening there. If you look at the latest image there, you can see some South Pole polarity coming through. Don't be surprised if the Earth never makes it into that South Pole current sheet, shown there in red. Next, we'll look at the line of sight coronal hole plot. And we see some large North Pole oriented coronal holes extending way down toward the equator. And here's the composite image, which also contains the poloidal fields. Solar polar fields shown in green and red there, as well as the solar magnetogram. Last but not least, we'll look at a magnetism diagram of the corona. The solar atmosphere is a chaotic place, and there's a few days. About 3 days of the magnetic field plots of the corona. Next, we'll look at electrons. We don't really see any charging hazards. We see pretty low levels of electron flux here. There's the 1-year chart of it, and we're expecting a fairly flat to slightly lower forecast here. I would concur with NOAA on this one. Going to see a flat to lower electron flux over the next 3 days. There is the 3-day chart of that measured by the GOES 16. Here's a visualization of the full air column, the total electron content forecast. This will show you where GPS errors will be happening, and we do see some anomalies here around the North Geographic Pole. You can see those blobs of electrons up there around the North Pole, as well as some over North America and Canada. So perhaps some GPS errors for some of our viewers as a result of those. And here's just a diagram of the altitudes of spacecraft and so on to give you a sort of a visual of where the Van Allen belts are located. And here's a diagram of the atmosphere. And what that red F on the right side there, that is the F layer of the ionosphere. That is where the GOES 16 makes its measurements. Here's a visualization of the ionosphere, and it's looking a little anomalous here. Southern hemisphere looking a little odd. I don't know how else to explain it. Some excessive charging of the ionosphere there in the southern hemisphere. Let's bring up the latest image. And that one coming in early today at 8:45 Universal Time, like our video coming early. Next, we'll look at volcanoes on volcanodiscovery.com. By the way, Mount Etna produced a 15,000-foot ash plume. Massive uptick there at Mount Etna. Let's see what it's on the list for today. Abico, flight level 090, 9,000-foot ash plume as it returns to the list. Semeru, 14,000-foot ash plume as it explodes. Popocatépetl likewise exploding. Larger ash plume there, 20,000 feet. Fuego exploding, 15,000-foot ash plume. Sangay exploding, 19,000-foot ash plume. Revenador and Sabancaya both also exploding. Flight level 140 and 230 respectively. Please don't hang glide over the calderas. It could make for an unhealthy day, and we need the views on YouTube. Next, looking at earthquakes over the past 24. Largest of the past 24 was a 6 magnitude in western South America. We'll get to it, but we see deep quakes. Quite a lot of deep quakes continuing here, starting with this 4.5 in the Aleutian Islands, the central Aleutian Island chain there, a 4.5 magnitude quake at 230 kilometers. Here's another deep quake before the 6 magnitude quake at Chile, close to it at Argentina, a 4.2 magnitude at 232 kilometers. Only 10 minutes later, a 4.6 deep quake at the Fiji Islands at 526 kilometers. And then at 1520, we see a 6 magnitude quake. And we are still seeing a drought of 6, 7, 8, and 9 magnitude earthquakes, folks. So please recognize that if you're in an earthquake-prone zone. You probably know more about it than I do. As while I've been in several earthquakes, I've never actually felt a confirmed earthquake. I find it kind of freaky. Next, we see a 4.6 at the Philippines. That's a deep one also. 127.9 kilometers depth. Very deep quake strikes Fiji at 1854 Universal Time yesterday. 623 kilometers depth there. A 4.4 strikes Hawaii. Let's check the location of that one. It's quite shallow, only 4.4 kilometers. And it's under the lower slopes of Mauna Kea. Second largest of the past 24 was this one here, in between the North American and European plates, a 5.8 magnitude in the Norwegian Sea, very far north. Here's a very shallow quake near Greenhorn, California at 2,000 meters above sea level. Let's check the location of that one. And there's where that happened, in Plumas National Forest. west of Lake Davis. 4.7 strikes Nevada. Small deep quake inland Alaska. So a lot of quakes on the list today, folks. Another deep quake at Fiji. 2 deep quakes. About an hour apart from each other. One at nearly 600 kilometers depth, both in the 4 magnitude range. So a bit of an uptick in earthquakes, but the drought of large quakes continues despite that 6 magnitude quake. There's another deep quake in the Solomon Islands. Deep quakes galore. Let's check nullschool.net for the jet stream scenario. There are the jet streams of the eastern world. And check out this extreme meridional flow right here. 180-degree bend going on near the Arctic. Here are the jet streams of the western world. And we're going to show you a snow forecast for the mid-Atlantic states momentarily. First, let's check and see what's going on with lightning. Massive lightning storm there going on as we make the video in the North Atlantic. Look at all the strikes. That is pretty epic. And here's the NASA GOES 16 lightning mapper. And that band of clouds seems to be moving to the east-northeast. So here's what's going on the U.S. Doppler radar map, and we see quite a bit of snow across most of the northern portions of the country. And let's take a look at some forecasts here. So here's the GFS forecast on Tropical Tidbits. And it is forecasting about 15 inches of snow for where I'm located. And SMASH staff and I are located right about there in Lehigh Valley, Pennsylvania. And that is through Thursday at 1800 Universal Time. Next, looking at pressure zones here. We're going to advance this into Thursday. And this is the GFS forecast. We're going to show you how the... Let's zoom in on this actually here. I'm going to zoom in on the eastern portion of the U.S. here. And you can see that low coming up the coast. Eastern PA expected to start to get hit with heavy snow starting tomorrow afternoon. And here's the Euro forecast. It's actually showing the low closer to the Pennsylvania-New Jersey border. And just give me a moment to check the life of the stream. Again, we are streaming live, folks. Thanks everybody who tuned in to the premiere. We greatly enjoy watching the videos with our viewers. As I would remind you that I'm not only smAsho, I'm also a client and the editor at large. Let's take a look at what's going on currently in the cloud layer. Using the NASA GOES shortwave radiation map, it's a 3.9 nanometers. Bunch of low clouds there over the Atlantic once again, as well as over the Gulf. Check it out, low clouds galore. And here's the water vapor map. Always interesting to see the difference between the water vapor and the cloud layer. It's not chemtrails. It's not contrails. It's natural phenomenon. Don't be an arrogant fool and think mankind is able to control the weather. At least not on a large scale. Yes, on a tiny scale, you can fire rockets at snowstorms and rockets at hailstorms, and you can fly little planes and crop dust certain little cells of weather and change their path a little bit. You can aim microwave arrays at clouds and change their trajectory a little bit, but you can't do it on a major scale, folks. It's laughable and arrogant and ridiculous to think you can. And we've got bonus features, and they're pretty epic. We're going to show you the close-ups of sunspot 2792, 2793. And there are those sunspots on the colorized magnetogram. I believe this one is an alpha class sunspot now, and this one, 2793, is a beta class. So still significant possibility of more solar flares, and again, significant possibility of coronal mass ejections, for which you don't need a solar flare. Okay, this is beta class as well. 2792 is beta class, 2793 is beta class. We've got significant filaments in between the Earth and the Sun right now, and we'll show you those coming up. First, here's the northwest quadrant in 171 angstroms. And you can see that filamentary behavior in the lower right, as well as a bit of a filament there. Great view of that. Here's the same area in 304 angstroms. And again, there are many filaments in between the Earth and Sun right now, or at least one major one, and you will be able to see it momentarily. And here's a great view of a filament right there. You can see approaching that arrow there. There is a great view of that filament. And that could release without a solar flare, folks. It's part of the reason why we have a channel. As we've found ourselves in a certain position here, I didn't butt in line. People requested that I go to the front, and so here we are. I'll let that play through one more time here. The activity out of sunspot 2792 and 2793. Here it is in 171 angstroms. We'll let that play through a second time. The C-class solar flare visible there, right there. That was the solar flare. And you can see some evidence of the coronal mass ejection in the 171 angstroms wavelength. Here's the southwest corner. Interesting how we saw ejecta come out of both active regions, and how, although we can see the active regions, the primary ejecta is on the opposite side of the Sun. Another example of how chaotic it can be and how solar flares aren't really necessary for coronal mass ejections. Part of the reason why we started making our videos about solar activity at solar minimum. Here's that area in 171 angstroms, and we'll close things out with the western equatorial view in 304. Big coronal hole there, also visible even in 171 angstroms. And here's an equatorial view showing you some of those filamentary behaviors. And it's about that time. Thanks again for tuning in, folks. Remember, stare at the sun, don't drink it. If you do, don't drive. And since it'll never be now again, may that solar wind be at your back.